Welcome to The Explainer. Today, we're actually reverse engineering a standard fifth grade math lesson. We're going to look at the hidden psychology, the actual structure behind how really complex concepts are broken down for young minds. We'll be looking right under the hood of a lesson plan created by student teacher Caden Black, and we're going to see exactly how a masterclass in foundational learning is built literally from the ground up. Okay, so picture this. You're 10 years old, you're sitting at your desk, and your teacher opens the morning math class with this mouth-watering scenario. If you have 24 cookies, what are all the different ways you can arrange them into equal rows? Now, this is the exact attention grabber used in the lesson plan we're dissecting today. It's brilliant, right? Because it instantly visualizes a math problem, turning something totally abstract into something incredibly tangible and, well, delicious. To understand exactly how this works, we're going to run through our agenda for today. We'll cover the lesson blueprint, managing the classroom, the teaching procedure, enrichment and games, and finally, assessing true understanding. Let's get right into it. Section 1, the lesson blueprint, and setting the foundations for factoring. Because, a teacher prepares long before that morning bell even rings. The primary goal here is wonderfully simple but absolutely crucial for math, ensuring students can actually define factoring, which is just breaking a number down into smaller numbers that multiply to make it. But here's the thing. The blueprint goes further. It lays out a specific behavioral objective. The student has to be able to state this definition in their own words with 100% accuracy when asked. So we're not just talking about parroting a textbook definition, it's about total internalized comprehension. And to actually build that understanding, the lesson relies heavily on tactile materials. We aren't just talking about pencils and pre-made practice sheets here. This lesson turns abstract math into a literal hands-on construction project. They're using physical counters, think beans or coins, array tiles for building out shapes, and these really visually engaging factor rainbows that the kids can actually color in. By bringing in physical, real-world items, the lesson plan makes sure that students who might kind of struggle with just staring at numbers on a page can literally hold the math right in their hands. Now on to Section 2, managing the classroom and setting the stage for learning. Because let's face it, even the best materials are pretty much useless without a focused environment. What is truly fascinating to me here is the clear contrast between preventative and interventive strategies. The lesson plan actually anticipates distraction before it even happens. Preventative techniques are built right in, like chunking instructions so the kids don't get overwhelmed, smoothly breaking factoring down from factor pairs to arrays to prime and composite numbers. But when things inevitably go slightly off the rails, because they're 10-year-olds, the plan relies on interventive techniques. Not yelling, not pausing the whole class, just proximity control, meaning the teacher simply walks a little closer to an off-task student to silently redirect them, or maybe uses nonverbal cues like targeted eye contact and gestures. It's honestly a masterclass in maintaining flow. Which brings us to Section 3, the teaching procedure, taking a chronological walkthrough of the lesson. Let's see how this builds in real time. This chronological pacing is so cool because it brilliantly illustrates a classic, highly effective 5-step escalation in teaching. First, it starts with the attention grabber, our 24 cookies from earlier, right? Then it moves to an introduction, connecting the new topic to stuff they already know, like multiplication and division. From there, it scales up into direct teacher modeling, smoothly transitions into guided practice, where the teacher and students are working together, and then finally releases the kids to independent or group mastery. It's like a perfectly structured off-ramp, going from total teacher control straight down to total student independence. Smack in the middle of this procedure is the teacher modeling phase, which uses this really fascinating psychological trick, the think aloud strategy. So the teacher might say, okay, let's find the factors of 18. But instead of just silently writing the answer on the board, the teacher speaks their internal monologue out loud. They'll start with 1 times 18, then verbally test out 2, then test 3. They're showing the students exactly how an expert brain systematically approaches and organizes a problem. They aren't just giving them the answer, they're literally teaching the thought process itself. Now, during this direct instruction, they also introduce a super vital distinction. Prime numbers, like 7, which only have 1 in themselves as factors, versus composite numbers, like 18, which have a whole bunch of factors. Now sure, this might seem pretty simple to us, but this specific concept lays the absolute essential groundwork for way more advanced mathematics later in their academic lives, like fractions and algebra. It's planting a very important seed. So, as the lesson shifts out of direct instruction and into guided practice, the teacher begins checking for understanding. But they move way beyond just basic rote memorization here. They start challenging the room with critical thinking questions. They'll ask things like, how do you know when to stop checking numbers? Or, why does every single number have 1 in itself as factors?
By forcing the students to actually articulate the why behind the rule, the teacher is verifying genuine comprehension. No lucky guessing allowed. Section 4, Enrichment and Games. Going beyond the basics. Because, of course, some kids are going to grasp these concepts instantly, and you need to have backup plans ready. And let me tell you, these enrichment activities aren't just busy work designed to keep the fast learners quiet. They actually push the boundaries of the lesson. The students get to explore prime factorization, like breaking the number 24 all the way down to 2 times 2 times 2 times 3. They can play games like Factor Bingo or Build the Number. But honestly, my absolute favorite part is the real-world extension, where they apply mathematical arrays to design actual seating arrangements or packaging. It instantly shuts down that classic student complaint, when am I ever going to use this in real life? Well, right now. Finally, we reach the climax of the teacher's journey in Section 5, Assessing True Understanding Through the Grading Rubric. This is how we prove the students actually learned the material. The real crucial takeaway from this grading structure is looking at how a student actually earns that top score of 4 favorable. Notice that it is not just about getting the right answer on a math test. To get a perfect score, it requires detailed, clear explanations and complex, refined mathematical reasoning. But the most brilliant part? Look at the checking row at the very bottom. To get a 4, the student's work must be checked by 2 classmates, and all the appropriate corrections have to be made based on that peer feedback. It literally builds collaboration and peer review right into the grading system. In her final reflection at the end of the document, student-teacher Caden Black beautifully captures the ultimate purpose of this meticulously planned blueprint. She points out that breaking skills down into clear, measurable steps actually makes defining expectations a whole lot easier. And she notes how incredibly important it is to balance accuracy with explaining the thinking process rather than just getting the right answer. It goes to show that a really great lesson plan is, at its core, a fair, structured way to assess skills while heavily prioritizing the why over the what. And this whole deconstruction, it leaves us with a pretty fascinating final thought. We've just seen the incredible rigor, the tactile materials, the behavioral psychology, and the structured rubrics used to teach a 10-year-old how to factor numbers. But think about your own life for a second. How could we accelerate our own mastery of complex topics, whether that's learning how to code, picking up a new language, or mastering a brand new role at work, if we applied this exact level of step-by-step psychological scaffolding to our adult lives? I mean, if this blueprint works so perfectly to build young minds, just imagine what we could achieve if we built similar rubrics for ourselves. Thanks so much for joining me on this explainer, and I will catch you next time.